So here's a point, and here's a point. We're going to call those, when they put their fingers, we're eventually going to call those foci. Now what's foci? F-O-C-I. Foci. As in focus. But there's two of them, so we call them foci. Now, on the rest of this little thing is a weird shape. What's this weird shape we're looking at? Somebody describe it in an old school sort of way. It's an oval. It's an oval. What do we call it? We're going to call it an ellipse because we're in math class. But it's an oval. It's an egg. Okay. Now the thing about an oval is it still has a center. Assuming I did this really, really well. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Ooh. 1, 2, 3, 4, 5, 6. That does not look like the center to me. Right about here's the center. Okay. Right about there's the center. So that's still the center, and it's still going to have to follow the same rules. Now the difference between an ellipse and a circle is an ellipse is a circle, but it's bent and broken, right? It's smaller. It's got a smaller radius one way than the other way. And so an ellipse in this direction has a distance of 1, 2, 3, 4, 5. So this goes 5 up and 5 down. And in this direction, I have 6. I'm going to pretend like it went through right here, so I don't have to do some rounding. So it's going 6 this way and 6 this way. Are we in good agreement? Okay, so I want to use my circle formula. The problem is my radius is all messed up. I can still use the idea, though, that it's x squared plus y squared. But now I have to do a little thinking because I can't just put an r squared on the other side. Instead, I must give each of the x's and the y's their own radius. What in fact is the radius in the y direction? Effective radius. 5. So underneath the y, I'm going to put a 5 squared. Meaning that if this was 1, if I multiply both 5 squared, I'd be making a pretty little circle. And in fact, if I put a 5 here, this would be a circle, right? Because then I can move the 5 squared to the side. But this one here, I need to be bigger, so what's radius going to be? 6. So I slap a 6 squared sitting right down here. Now, what if I want to move the center? What would I do? Not the bottoms. I'm just getting the same thing I did before. I'm going to put a plus h here and a plus k here, right? Same rule. It's a circle-ish sort of thing. And that's how you graph. That's the standard form for a parabola. Not parabola, sorry, ellipse. Parabolas are later. So if you look there, I've got x squared plus h. If you look at the formula sheet 2-3, I got x squared plus h over a squared plus y plus k squared over b squared equals 1. The center would therefore be located at negative h, negative k, right? Opposite we expect. With me so far? Sussman, you with me so far? You're on vacation. All right, good news. Okay, A is the distance in this direction, because underneath the x, the square root of whatever number's down there, in this case 6 squared, so it'd be 6, is how much we go this way and this way from our center. B, whatever this number is how far I go up and down from my center. Good so far? Now, if this is bigger, we call it the major axis. If this is bigger, we call it the major axis. In this case, it's not, so we call this one the minor axis. Those are words you technically have to kind of know. Major means big, minor means little. It's probably not that big a deal. You know what axis means, so it should be good. Now, I do have one bit of bad news. There's one more bit of information we must find, and that is where the foci are located. Now, you might be thinking, Mr. Resney, why do I care where the little dots they put their fingers on? Why do I care where those spots are? not useful to me. I'm willing to live my whole entire life without that. And maybe the most useful thing about this. Let me give you two examples. One, a guy named Johannes Kepler discovered that the Earth was in fact traveling in an ellipse. He also discovered that the sun was the foci. It was much closer to the middle because it's much closer to a circle. The farther he's out, the more flat it looks. The closer they're in, the more it looks like a circle. Now, that is one of the premier discoveries in science. Why? Said differently, that means that we go around the sun. I mean, if you're going an egg-shaped pattern in the sun, it's in a foci, we're going around it, aren't we? Yeah. That's actually the person who discovered it. Whoever you think discovered Copernicus, Galileo Galilei, no. Only Kepler did. Second thing is this. Let's say you're one of the people that wears one of these, or you wear the kind that go in your eyeball directly. When the optometrist wants to bend a lens, they need to have a curvature to it. They need to have an ellipse to it. So to do that, they have to figure out where the foci are. They literally take the cutters, put the cutters in the spot, and they grind around the spot. That's how they make your glasses. And all optical equipment. There are dozens of other examples. Foci are actually important. Okay? Oddly so. So I need to teach them to you. You'll forget about them. You'll look them up, Google them 5 years ago from now when you need them. Fair enough? Well, I'll teach it to you now. I'll beat it into you so you know the formula. So how do I find where the foci are? There's a magic formula. The magic formula is written right there, and right in the middle. It says C equals A squared, better be careful, minus B squared absolute value. Square root. Does this work? Let's hope it does, because we have an ellipse right in front of us, don't we? And shouldn't we be able to figure out what this foci is, where this foci is? Let's do a little math age. Let's hope for the best. I feel like we're way off, but we'll find out in a moment. C equals, what's A for my problem? 6. I'm glad somebody's following along. Good job on you. Minus 5 squared. Absolute value. C equals the square root of 36 minus 5, which is 36 minus 25 is 11. Absolute value of 11 is the absolute value of 11. We got that. It was at 4. That's like 16. We're way off. It should be better than that. Oh well. Usually works better than that, but it didn't work too good today. I apparently did not do a good job on my little string. It is a little bigger, but technically 6.2 would not make. Oh yeah, it would make it bigger. Yeah, if I use 6.5, that might be the difference, right? Because on this side, I think I came up short, which is why we're weird on this side. This side is about 6.5, so if I went 6.5, I'd be a little close to the right answer. That said, I'm not. Good so far? Okay. Now we want to find the foci. The foci are always on the major axis. They're always this distance C from the center. So if the major axis is this way, the fingers would be this way, and the ring rope would be going this way, so therefore the foci would have to be on this axis if it was the bigger one. Everybody good? I just taught you everything about ellipse in like 4.2 seconds. So, let's take it. Yes?
Wait, what are the two dots called?
These are called foci.
The foci are always on
major axis, the big axis. All right. So we're turning this page. Let's see how we do. Everybody try to graph number 1. Go. All right, let's do it. I got graph paper here, graph paper, boom. Colors be something like this, plus, good. Whoop. Okay, so I got my graph paper. Equation is x squared over 9 plus y squared over 4, over what? 16? Doing math in my head, not good. Okay, and it says find the center, foci, lengths to the major axis, lengths to the minor axis. For each ellipse, the equation is given, and then draw the graph. I'm going to draw the graph first because I'm lazy. I noticed the center would be where? Hey, there's no H and K, so how do I find the center? Where's the center? 0, 0. Love it. 0, 0. It's going to be the center. It's not moved. That's where we normally put it. Next, I'm going to go how far left, right? Square root of 9 is 3. So I'm going to go plus 3 and minus 3. That's actually part of what this is. But that's okay. We don't remember that. We're just going to go 1, 2, 3, boom. 1, 2, 3, boom. And then in the other direction, how far are we going up and down? 4. 1, 2, 3, 4, boom. 1, 2, 3, boom. All right, there's my ellipse. I'm going to try to draw it so it doesn't look like a little diamond-shaped weird thing. That's one of my better ellipses in my lifetime. There you go. Make sure you mark your points on this test if you draw like Mr. Sussman does and I do, and you draw these weird diamond things. You kind of need to let me know what you were thinking so that I go, oh yeah, that's an ellipse. It's just badly drawn. Okay, now I got a list of things I need to find. Where's the center? The center we just said was at 0, 0. So my center's at 0, 0. I'm going to skip foci temporary. What's my length of my major axis? That'll be the longest length, which is, I heard somebody say it, 8, thank you. And then my minor axis is 6. Love it. And then, okay, now I got foci. So how do I find my foci?
What's the foci?
The foci are the two places where I put my fingers to make this thing happen. First of all, it's got to be on the major axis. Second of all, I got to use the magic formula. The magic formula is C equal to the square root of the absolute value of A squared minus B squared. Boom. Whew. C is equal to the square root of absolute value. What's A? A is 9, 3 squared is 9, minus B squared, which is 16. Right? C equals the square root of, negative 7. It's absolute value, so it becomes 7. That's good news. So it's 7 from the center, correct? So that's good. You should get no. Square root of 7 for this. Oh, square root of 7 for that. Thank you. So square root of 7 for the center. So that's 1, 2, 7's between. So it's right about here, isn't it? Ish. I'm going to put foci here. Put a foci here. Now, what are those points' location? I still have to write down the location. Where's the location of my two foci? It would be 0, square root of 7 and 0, negative root 7. Am I okay, Tippins? Yeah. Okay, that's it. We're done with that problem. It's a beautiful thing. Questions? All right, move on to the next one.